Hipsters will be able to graph equations. Using plug and chug. Using plug and chug. So what I want you to do, the first thing that I've asked you to do on your classwork for today is I've given you a Venn diagram. I've given you two different problems. We all know how Venn diagrams work, correct? Yeah. So in the middle are the things that are the same about these problems. Same about what they look like or how we work on them or the things that we do the same. On the left-hand side are things that are only true about this left-hand equation, and on the right-hand side in this space is things that are true about only the right-hand equation. I want you to work with your partner right now. Fill in the Venn diagram about this problem. I want you to think about the things about how they look, what we know about the equations, and how we solve the equations. So specifically think about those three things as you're filling out the Venn diagram. I'm going to give you about 1.5 minutes to do this with your partner. All right, let's get this Venn diagram filled out. Somebody share out. Let's start with the centerpiece. Things that are similar. Alyssa. There's unknown variables. Specifically, there are, how many of them? 2 variables. What do we know about equations with 2 variables? Does anybody remember what we know about equations with 2 variables and no exponents? What do we call them? What's specific about equations with 2 variables and no exponents? It is a vocabulary term, so it is something that you do have to know. Bianca? So they're both linear equations. So they're both going to graph a line. Other similarities. Other things that are the same. Jeremiah.
They both multiply and divide. Well, not multiply. They both multiply, okay?
Both have multiplications. What else? Esteban. Esteban's thinking ahead to how we're going to solve them. He knows that for both of them we use plug and chug. Geronimo. Okay, he says we use 0 to plug. Specifically to plug in for what in both of them? The x. We use 0 to plug in for x when we're solving both of these. Any other similarities? Yes? Say it one more time.
That they could be both fractions.
Yeah, we can have equations in both of these fractions. These both don't, but we definitely could. So the ones that I think are most important here is that they are both linear equations. We use plug and chug for both of them. And then in both of them, we use 0 to plug in for x. Okay, let's move on to the left-hand side. What are things that are true about the left-hand side equation, that are only true about the left-hand side equation? Monique. The x and y are on the same side. What form of the equation is that? What do we call that form of the equation? Standard form. Okay? What else is true about only this equation? Diak. What? I think that's being a little bit too specific, but generally when we see equations like this, Geronimo? Yeah, so we plug in for both x and y in this one. We plug in for x and y in this one. Sandra. Say that one more time. Yeah, so in this one, we plug in x and y, and I think we're going to expand on that based on what Cassandra says, is we use 0 for both. I'm going to underline both there because we already said that we use 0 for x in both equations, but in this one, we use x and y are both 0. We try them both. Any other things about this equation that we do only for this type of equation? These are both excellent. Let me add on a third kind of important detail, is that we usually graph after 2 points. To help choose a third to check. Third check point. Okay. Now, how is this equation different from this one over here? What's different about this equation? Richard. Yeah, so it's solved for y. Don't do that. All right, there we go. It's solved for y. Specifically, when it's solved for y, and specifically with this form of the equation, what do we call this form of the equation, Lydia? Yep, so this is slope-intercept. Right? So that kind of gives us the physical description of what's different about this one. What's different about how we solve it? Esteban.
We have to choose the x values.
Yeah, we choose only x values. Choose only x values. Anything else that's different about how we solve this one? Geronimo? Yeah, so it's only, there's no equation solving. So we can just multiply and divide. Or multiply and add. Yeah, so this is super important. It's solved for y, we call that slope-intercept form, and we choose only x values. So, when we look more globally at our Venn diagram, we should notice the big difference between these two things is how we choose our values. So for this one, we plug in x and y are both 0. For this one, we only choose x values. So we still plug and chug for both. Still plug and chug for both. The difference really is how we choose our values. So we have to recognize for standard form, we plug in x and y. For slope-intercept form, we choose only x values. And I think that's the big difference that we struggled with, a lot of us, when it came to doing our work on our homework and on our do now, is we weren't recognizing the difference of the two different forms of the equation and how we solve them. Okay? So what I want to do, just really quickly, is I'm going to work with you to create our XY chart and get our XY values chosen. And then I'm going to let you guys do the work. Then we'll check it. So this is going to be kind of like together time. So starting on the left-hand side, what values do I want to choose for the equation here on the left-hand side? Daya. 0 for what? What else? And for y. And since we usually graph these 2 points first to help choose our third checkpoint, I'm going to stop right there. And I'm going to let you guys solve that one on your own in a second. But first, let's come over here and get started on this one. So for this equation that's in slope-intercept form, what values would you like to choose? Alyssa? I'm going to put down the 0, and I'm going to ask you to think twice about the 1 and the -1, just based on what you're multiplying by. You're going to be multiplying by 1/2. 2 and -2. So we want to be using, when we have a fraction that we're multiplying by, we want to use that denominator and its opposite. That's going to be the easiest way to go. Okay? All right. I'm going to now give you guys an opportunity to go ahead and solve these on your own. When we start solving this first problem, the first thing we really should do is leave chain switch. That way we don't make any mistakes. So the first thing I'm going to do with this particular problem is I'm going to leave chain switch this equation. So I'm done with all that subtraction. A lot of you didn't do that first. It's definitely something you need to think about. And when you do that, you're going to get a -y. I'm going to urge you to put the coefficient that belongs there. It's not just -y, it's -1y. Because a lot of you aren't thinking about that. And you get down and you get -y equals something. And then you're done. Well, you're not. So let's go ahead and come over here, and we're going to plug in our first point, which is x equals 0. So that's 4 times 0 plus -1y equals -4. This becomes 0 plus -1y equals -4, which is just -1y equals -4. So many of you, because you just had that -y, that negative just disappeared, or you just said, all right, well, y is equal to -4. This tells us there's still one more step that we need to take here. Lonnie, what is the one more step that we need to take here? Yeah, we need to divide both sides by -1. So that tells us this is a good date, so that is y equals +4. So most of you, not most of you, many of you told me that y was equal to -4 because you never had that coefficient over there to remind you that you needed to divide by -1 as that last step. So come down, fill it in. Y is +4. Yes, Monique? Yep.
The whole lesson, like basically we're just reviewing things we've done in the past few days.
Mm-hmm. Yep. So y equals 0, that's our second point. That's 4 times x. No, that's not how I normally write that. Hold on. 4 times x plus negative. So plus -0. Well, okay, that's obvious. -0 is still 0. So we get 4x is equal to -4 divided by 4. Tells us that x is equal to -1. So we're going to go ahead and graph those 2 points that we already have. And I'm going to use a straight edge to draw my line.
Yep.
And hopefully that should lead us to another place where we should have a point. So I look like there's probably a point here somewhere at x equals 1. So I'm going to plug in x equals 1 as my final checkpoint. So for x equals 1, I get 4 times 1 plus -1y equals -4. That's 4 plus -1y equals -4. Now I need to go through and solve this equation. Jasmine, what's the first step to solve this equation? Yep, going to add a -4 to both sides. -4 plus 4. Gives me -1y is equal to -8. Last step, make sure that you divide by that -1. Gives you y equals +8. So come back in, put that on our chart. Graph that point over 1. Excuse me, up. It's +8. That's what we solved over there, +8. Over 1, up 1, 2, 3, 4, 5, 6, 7, 8. And sure enough, that is indeed a point on our line. So we have checked our work. This side's actually a lot easier. Kip yes or kip no if you agree that the right-hand side's a lot easier. Yeah, slope-intercept form is a lot easier. It's pretty simple plug and chug. So I'm going to come over here. I'm going to plug in. Actually, first I'm going to go ahead and exchange this to a y equals 1/2 x plus -3. Get that leaf change switch in there so we don't make any mistakes. Then I'm going to plug in x equals 0. So when x equals 0, I get y equals 1/2 x, that's 1/2 times 0, plus -3. That's y equals 0 plus -3, so y equals -3. Come down and put that in the chart. And move on to our next point. We chose x was equal to 2. When x equals 2, y equals 1/2 times 2 plus -3. Turn that into a fraction really quickly, top, top, bottom, bottom, so that's y equals 1 plus -3. Y equals -2. So come down and put that in our chart. And the last one, x equals -2. Y equals 1/2 times -2 plus -3. Cancels out, but that's still a bad date. So Brianna, we still get that y is equal to -1 plus -3. So y equals -4. Finally, we'll come down and put that in the chart and we'll graph. So 0, -3, over 0, down -3. Over 2 and down -2. And -2, -4, back -2, and down -4. Looks like everything lines up here. Check out your straight edge to get it in there. And draw your line.